So these are also rose graphs, but all of these have an even number next to the theta as that coefficient. So that's going to change what they look like by quite a bit, actually. So let's take a look at 3 cosine 2 theta and see how this is built. So 3 cosine 2 theta starts here. Now I'm kind of expecting 2 petals here, but pretty quickly I'm going to be able to tell that's not the case. So when I get to right about in here, this is about pi, pretty close. So I'm not done with my polar graph. So I'm going to go all the way around. That is my 0 to 2 pi. So even though I have 2 theta, I actually have 4 petals. So we're going to note that the domain here is going to be from 0 to 2 pi. And remember, when it was odd, pay attention, this one was 0 to pi. And this is going to matter whenever we do our area. So 0 to 2 pi. And then this is always going to be double the number of petals. So if I see 2 theta, that means I have 4 petals. If I see 4 theta, that means I have 8 petals. Right? And then here is your distance out, right? So 3, 3, 3, and 3. So it started off here, went through the origin, came back, went out, again went through the origin. Not bad. There is your 4-petal rose. Now notice that there is symmetry. So I have symmetry around the x-axis. I also have symmetry about the y-axis, but the symmetry about the x-axis is my concern because of cosine. So let's go ahead and note that. All right, cosine. Okay, symmetry about x-axis. And then we're going to put a little note here. Always on the x-axis for even and odd number petals. So you're always going to have a petal that is on the x-axis when you're dealing with cosine. All right, so again, this is even. We're going to have in theta. We're going to have 2 in petals. All right, so when I think about 8 petals, that's a little strange to look at. So let's take a look at that graph. So 2 cosine 4 theta. Go ahead and just type it in real quick so you can kind of see what that looks like. Man, like, yeah, see 8 petals? It's got a petal on the x-axis. So if I watch it be built, man, that's so incredible, isn't it? What a neat process to build a polar graph. So there are your 8 petals. You're basically going to end up with 3 petals in the top, 3 petals in the bottom, and then you have 2 on the axes as well. So a little bit harder to draw that. I'm actually going to skip that just for time, although I would suggest that you do it. I do want to spend just a second talking about sine, because you're expecting for a petal to be on the y-axis, and it's not. You are not going to have a petal on the y-axis. So let's take a look at, what was that? 3 sine 2 theta? Yep, just making sure I had that typed in correctly. So 3 sine 2 theta. Again, you can watch this build. So there's your first petal, but then you're going to go down into quadrant 4, then quadrant 3, and then quadrant 2. So again, 0 to 2 pi. And I do have symmetry about the y-axis, but I don't have a petal on the y-axis. So I'm going to go ahead and draw that. This is my length. All right, so it's a little bit difficult to do diagonals at that length, so that is a little bit tricky. But we're going to go out about 2 units-ish, right? So 2-ish units, and then 2-ish units, and then 2-ish units. All right, so close enough. Kind of looks like a butterfly. All right, so now let's make a note about this symmetry. Oh, I put that on the wrong one, didn't I? I put it on the wrong one. It's supposed to go right there. Because this one is going to have 4 petals. I'm sorry for the confusion. This is going to have 4 petals, and this one's going to have 8 petals. So let's make a note about sine. So sine, it does have symmetry. And the symmetry that we're concerned a bit with is about the y-axis. But even petals, no petal on the y-axis. With odd, we do. But with even, we don't. So with the odd, see if I can go back. With odd petals, here, we did have a petal on the y-axis. We did have one petal on the y-axis here. But down here, we do not have a petal on the y-axis, even though we still have y symmetry. My suggestion to you is to go in and fill in these two graphs using the given notes.